Wanted to talk briefly about a technique for writing data to chain. And as you may or may not know, there are many ways you could write data to chain. You could even actually put data, stuff it inside an unlocking script, but that's very rare. People don't usually do that. Usually, data is written in the locking script side, or rather the output side of a transaction. And in fact, the most common way people write data to the BSV chain is in the op return. Op return, you may or may not know, was not designed for this. It was designed for a whole different reason, longer story. But you can do it, so no harm, no foul, and it works fine. A lot of people think it's even better because it's not in the UTXO set. So this quick video is talking about some of the differences between writing in an op return and then how the push drop operates. Push drop is a technique that you can use to write data to the chain. And the big difference, although there are several, but the big difference is that the push drop is actually contained within a UTXO. So that is an unspent transaction output. It can be as low, of course, as 1 Satoshi, but the ability to spend that later gives you an aspect of economic control. The other quick thing I want to say about the push drop that is very unique is that you have the ability to put an ECDSA signature over the data payload. So in the locking script, so that is the output side of a transaction build, you don't put typically an ECDSA signature, and that signature is not validated by the miners. It's purely for attestation purposes. So it's like signing a check means you can spend the money that's in the account versus notarizing a document. That's the big difference between the two. And then the even cooler thing is that the key that you use to sign that data payload can be tied back to BKDS-derived address. So I've done another video on BKDS. It's BRC 42 and 43 actually. And so those two things, those two concepts, the push drop shape class, if you will, and the BKDS wallet derivation, those are tightly integrated if you do it right. There is a class in the TypeScript SDK for this. I don't know if any other languages have implemented the push drop, but it's conceptually laid out in that class. So I think that's it. Oh, the other piece is that when you create the push drop output, like any output, you create a locking script. Of course, for the op return, you don't create a locking script because it's not a UTXO. That's a sidebar. But for the push drop output, you attach a public key. It's a P2PK script, not a P2PKH. So you attach the public key, and that public key can be to anyone. It can be to another party, or it can tie back to that same key that you used to create an ECDSA signature over the top of the data payload. Hope that makes sense. I think I got everything there that was in my head about that.
Got a curve in the game, laid out clean with the point named G and a math machine. Pick a secret number, that's your key. Multiply G, now the public can see. On the curve, can't fake what you sign. Private stays yours.